Hi ladies. So Max is sick today and I have to stay home with him. So I'm going to try to make a little video about 10.3 to help you through it. I think what I'm going to do is I'm going to postpone the quiz. So don't worry about taking a quiz next class. But just try to go through this video as well as you can and do the best you can with the homework. And then when I get back next week, we can talk about 10.3 if there's anything we need to follow up with, and then we'll do 10.4 that day as well. So before you do 10.3, it would be great if you haven't done so already to go through the 10.2 homework with each other and try to help each other out. I don't know who's going to be covering my class today, so I don't know if it's Dr. B, then he could definitely help you, but if not, try to help each other as best you can and make corrections on your homework. And then when we have class next week, we can go over anything that you weren't able to figure out and help each other out with. So just hold on to your homework, and we'll make sure that everything is all understood before you give it to me next week. But once you've done that, then we're going to talk about 10.3, which is arcs and chords in circles, of course, because the whole chapter is about circles. So this is actually one of the problems that I did for homework in yesterday's class, but this is not the easiest way to do it. If you could do it proportion, but this was one way to do it. But for this one, I can't write on this right now, unfortunately, because I'm not at school. I don't have my smartboard pens and stuff with me. But another way you could do this is you could say 70 is some amount out of the 360 degrees of your circle. So 70 out of 360 has to be equal to 7.94 out of C, out of the entire circumference, right? So you could say 70 over 360 equals 7.94 over C for circumference, and you get the same answer. So that just is a note there. And then this was another question. I don't know which one that was. Okay, so here's 10.3. So just to remind yourselves, remind us, a chord is a segment whose endpoints lie on the circle. Anytime you have a chord that's not a diameter, it separates the circle into a minor arc and a major arc. Okay, so if you just look at the circle down here, just because it's there, so we have this chord FG, and so arc FG is the minor arc, and then FJG, for example, that would be the major arc that chord FG breaks a circle up into. If the chord is a diameter, then it separates into two semicircles. So, but we're talking about not necessarily semicircles today. So there's basically three big theorems in this section. You don't need to know the names or anything. But the first theorem says that in a circle, in one circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So, and it's if and only if, so it goes both directions. So minor arcs, so for example, if if chord FG, no, let's start over. Sorry, it's early. If minor arc FG is congruent to minor arc JH, then that means that their corresponding chords are congruent. So that means segment FG would have to be congruent to segment JH. So we are going to do, I did do the proof for this one in the other class. It's not necessary. I'm not going to give any proofs on the quizzes or the tests or for homework or anything, but I just think it's kind of a good proof to go through because it kind of points out some interesting things about circles. So the proof is already done, unfortunately. So you get to a spoiled surprise. But I used just the same exact picture. So I said, given that we had congruent arcs, prove we have congruent chords. So if we have congruent arcs, what does that mean? Well, from the last section, we learned that it means that their central angles have to be congruent. So if we have this arc FG, then its central angle is the angle FLG, okay? And then if we have this arc JH, its central angle is JLH. So if these two arcs are congruent, and I just marked them with tick marks, then their central angles have to be congruent, and that's that little blue tick mark up there for the angles. Well, once you draw those central angles, then you realize that you've got a couple triangles in there, right? And with the triangles, all the sides of these triangles, except for these two chords, are radii, and in a circle, all radii are congruent, so I just marked all of these sides as being congruent. And then we could say that this top triangle up here is congruent to the bottom triangle because of side angle side. So triangle FLGG is congruent to triangle JLH because of side angle side, and because those triangles are congruent, then we know that the chords are congruent because of corresponding parts of congruent triangles are congruent. So again, you don't necessarily need to worry about the proof or be expected to do on a quiz or a test, but it is kind of a nice proof to do because it just reminds us that in circles all radii are congruent, and that can be a really useful thing in many of the types of problems that we're going to be solving. So then here's some examples using that theorem. Okay, so again, sorry that all the answers are there, but for this one we have these two arcs are congruent. So what does that mean? It means their chords have to be congruent. So that means that 38 has to be equal to 4x plus 10. You go ahead and solve that. Okay. For number 2, we have two chords that are congruent. So that means, remember, it goes both ways. So if these two chords are congruent, then the arcs are congruent. So this arc KL was marked as being x degrees. So that means JK also has to be x degrees because they're congruent. So then x plus 70 is 360 degrees. And then you solve that. And just, I should have said this before we started these, but one thing you might want to do when you're going through the video and the notes is before we get to the practice problems, like pause the video, try them on your own, and then look at the notes that I have about how to solve the problems. Okay, so for number 3, we know we have congruent arcs because they both have the same angle measure marked, so they have to be congruent chords. So that's your equation right there. And then in the C block, we didn't do this one. But again, we're saying we have these two little chords that are congruent. They have little tick marks. So that would be 5x minus 1 would have to be equal to 4x plus 7, and you would solve that and get whatever you get. Okay, things like x equals 8 maybe. So that's that first big idea in this section. The next thing that we're going to talk about is bisecting arcs and chords. So bisecting an arc is the same concept as you would expect it to be. It's just, separating it into two congruent smaller arcs. But the theorem in this section says that if you have a diameter or a radius of a circle and it's perpendicular to a chord, okay, so here I have this radius CB. It is perpendicular to chord XY. And so what that means is that the chord is being bisected, and also that means the arc is being bisected. Okay, so that is that concept right there. This next theorem is just the converse of that. So it says if you're bisecting a chord and it's perpendicular, then it has to be a diameter or radius. So it's the same concept, just the converse. Okay, so again, at this point you might want to try to stop the video and do some of the practice problems, or maybe just listen to me talk about one of them and then pause it and try the rest. So just one thing about this book that's a little frustrating. Again, it's a new book, so I didn't necessarily see this coming. When it talks about arc PQR, that's how you name a major arc, right? So a major arc is named by 3 points, and a major arc always has to be greater than or equal to 180 degrees. But in this problem it says the measure of arc PQR is 98. So they're obviously not referring to a major arc, it must be a minor arc. So that's just something to note here. I don't know if this has happened too much in your homework yet, but you just want to like think about that. So technically they should have said the measure of arc PR is 98 degrees. And then so I just drew that on this picture. And then we have here this radius that's perpendicular to that chord. So what does that mean? It means the chord has to be bisected and the arc has to be bisected. So if the whole entire arc is 98, then half of that arc would be 49 degrees. And then the second question, it says circle S, find PR. So PR is all the way across. They told us that, sorry, I don't know if you can hear that, that's my cat like running around like a crazy person. This segment, TR, is 6. So because the radius is bisecting the chord, PT also has to be 6. So the entire length of the chord is 12 units. And I have to pause for a second because I have crazy cats.